This is a quick video for the beginners, technicians, and not for the experienced ones, people working in the RF field or radio frequency field. I'm going to show you how I made it two type of connectors, two different cable brands. This is TRILOGY cable, white cable, using their own type of connector. And this is RFS cable that uses their own cable. And it's like two brands having fun, having sex. It's the white cable, and this is a male, and this is having fun with RFS, the other brand, which is a black female connector here. I hope I don't sound impolite, but when you do work, you need to do what you love. Otherwise, work is just being on the grind and trying to stay afloat. So have fun with what you do, but do quality work at the same time. So don't cut corners. And here, like I said, it's a male connector made by this company connected to a female connector made by the other company, RFS. And I've used some mounting clamps here. As you can see, I secured the cable on the wall. I was not supposed to do this part. It was a job assigned to the electricians, but I had to do a couple of other things here, including installing some splitters. So now I had to come back to install the connectors because they had to replace a cable. It was some cable damage done while pulling their cables, and I'm here and I'm almost done, but I'm going to show you what's in a connector box. This is made by RFS. These both companies or other companies like Andrew uses the same standard, LDF 450A cable, similar size, very similar impedance, like a 50 ohm cables, but they used different techniques and different technology for their connectors, and some are easier to use, some are better if you use it's easier for you if you use a preparation tool. I recorded how to do it in different other videos. This is a little piece of paper showing you how to manually prepare using a hacksaw, a knife, or if you want to use a stripping tool. But what's important here, and it's one of the reasons I record this thing, this is not just a suggestion. You must measure, you must follow the instructions, especially measuring the length, the cutting length here. If you see here, 24 millimeter. So if you go by inch, I rather use metric system when I measure stuff. And including, you see the tip of the ground sleeve here. So cut is on the top or on the tip, right? So those are important instructions. So and I'll explain you why by showing you the connector. So the length of this central conductor is also very important, 6.5 millimeter. So if you use inches, depends how good you are with your measuring tape, but it's not just a guesstimate, it's a very precise measurement. If you use a preparation tool, like I have one somewhere, I had to use two different ones provided by this manufacturer. So I have preparation tool provided by TRILOGY or bought from TRILOGY, and one from RFS. And they are precisely designed to cut a exact length. So I don't have to worry about, just use I'm using the drill and I drill the connector, clean it up, I mean the cable, clean it up, prepare using later hand tools, and for the trilogy, I need to specify that they use is kind of a coating made out of plastic, like a glue type. It is not a glue, it's a coating, and I'm using heat, but I'm not using a big torch in order to get rid of that soft glue or soft plastic. I use a bit of heat, then I use a piece of paper to remove. Once that one softens, I remove. So I expose the central conductor, and I avoid scratching it using some tools or some knife. Some people think that using a knife is okay to remove that glue, but it's not okay. I recorded this type of procedure in different videos. For today, I'm just going over the general idea of mating two cables together and nicely secure it on the wall here. So clamp here, clamp here, clamp here, and it's secured. People won't damage the cable, because if you just leave it hanging, like I've seen people doing, other people start working in the communication room and grab on the cable, hold stuff. Many times they use their, let's say, alarm cable securing to our radio frequency cables, and they get heavy. So you have a bundle of cable attached to your cable, your RF cable, and you don't know because you left the site. And it can affect the signal levels when they kink the cable, or they, let's say, if you don't install the connector right. So lots of things can go wrong if you start doing a crappy job. You attract crappy people around, because that's your mind. So if you think that you want to do some shortcuts because you don't like what you do, likely you work for someone who hired you because the way you think, like being fast, doing cheap stuff, and they will send you on customer sites and customers with similar vibe. And I might talk nonsense here, you don't have to understand what I'm saying, but I have enough years of experience and enough gray hair to tell you from my experience what I've seen, human behavior. So you must follow the instructions sheet here. And why is that? I'm going to explain a couple of seconds. Here I have a sample of a broken connector. Someone sent it to me broken. They thought I'm Jesus to fix connectors, but I can't fix plastic. And when I look at this one, I don't see marks of previously used tools, like someone used a wrench to remove this one, like I installed it and removed it. But what I'm saying about this connector, and let me show you another one. So I have another connector here, that's a male, but it doesn't matter, it just the head is different. These are one-time use. You mount it, so you strip your cable, prepare your cable, install it on the cable, and if you want to take it out, what? You can't take it out. I mean, I have a way to take it out without damaging this gripping tool here, but if you give this ones to an electrician to install it, if they have to remove it off the cable, you have to save the connector. If they think they can save the connector, they don't have the technique, so they might use some screwdriver to expand this thing so they can pull it out. So I'm not sure what happened to the other connector. I have one here that I saved So this is a preparation tool for the RFS cable, and let me grab the other one. That's for the TRILOGY cable, and I saved this one. I might reuse it for different projects, or not for this one, for some other maybe hobby stuff. I had to remove it, like I cut it from an antenna from the roof. It's a dusty place here, so later I'll undo it and I'll remove it, because I have a technique how to remove the connector without damaging that plastic grip side of the connector. So I'm going back to talk about the turn it off, to talk about this connector, why it's important to cut it right. So if you cut this center conductor too short, so cable, center conductor, which is an aluminum alloy coated with a tiny layer of copper. I explained in the past, the radio frequency travels outside the cable, like outward, outside of the center conductor, like the top layer, not in the middle. So for that reason, and for economics, they use aluminum. It's cheaper and it's lighter, the cable is lighter, and just the surface is coated with a layer of high quality copper. And if you cut it too short, the inside part of the connector, this female grip part, right in the center, it won't grip the whole length. And the way they calculated the impedance and the electrical, not RF impedance, but also electrical impedance, they calculated for that length. The TRILOGY is using a way longer center conductor to grip onto the female side of the connector. Is their reasons. I don't know how they calculated this engineering stuff, how they calculated the minimum length of the center conductor for better grip, and like a mechanical grip and better impedance. So you have to have that 6.5 millimeter, but if you cut it too long, let's say you use a hand preparation method, the way they describe here, and you think, oh yeah, I'm just going to chop this cable, cut it, and do my cheap job, so I go home and watch Netflix. If you do that, if you cut it too long, what happens? It's going to be the tip of the center conductor is going to reach the bottom of that part of the connector, the female side of the connector here, and it's going to create a gap, an air gap, and the air has different impedance for the RF. So it's important to have a smooth transition between the dielectric foam and inside part here. Otherwise, like I said, you will have a change between the air and the foam dielectric. So you will, that air gap is going to change the local impedance. And when I talk about the kinks in the cable, I give people the analogy with a garden hose. So the garden hose, when you want to spray your whatever plants, if someone is driving over, or the hose is kinked somewhere, then you'll get a lot lower pressure at the hose head, or at the nozzle, whatever you use to spray your plants. And in this case, I'm going to use different analogy I just came up with. The BDA can consider your heart. So the BDA is a bidirectional amplifier, can be considered your body heart. And this pump, the heart, has two circuits, one for the brain, one for the rest of the body. And also it has this two circuits are closed loops. So veins and arteries is pushing the blood through the veins to the body, through the tissues, and all the way to the cells, and gets back the lower oxygen and blood loaded with carbon dioxide after the burning process in the cell at the cellular level. It comes back through the veins, back to the heart. So it's like two circuits, one for the brain and one for the rest of the body. And so that's the heart. It's a very specialized pump. The BDA in this case works in a similar way. It has two circuits. One in this case goes somewhere outside to an outside antenna, and one it's indoors, but it's still two-way communication. So the bidirectional amplifier will broadcast out to the cellular. Let's say if you install cellular DAS or distributed antenna system, so broadcast out through the same coaxial cable, but on different frequency band will receive back from the cell tower back into through the same cable, like a vein and artery, same circuit, back to the heart or the BDA. So that's the analogy I'm using. But regarding the kinks, if you have a kink in the cable, the heart will have to work harder, like the pump in your garden hose example. And if you have, let's say, regarding impedance, you have calcification. That's one classic example, especially now with the pandemic. People are dying. People don't know why, and some people try to blame vaccines. Other people try to blame the stress. Actually, I blame the stress, but I won't get into that topic because it's beyond the RF topic here. So when you get calcification on your arteries, it changes the local velocity, the blood velocity. And if you have multiple spots with calcification, it's not only decreasing the diameter, the passage for your blood, but also can cause like constrictions and a lack of flexibility of the vein. So the veins and artery are supposed to be elastic, flexible. So when the pump is pumping stuff, the extra shock pressure from the heart is being taken by this expanding and contracting blood vessels. But if you have calcification, the stuff is hard, make it harder for the heart. And also the tissues, each cell get less amount of oxygen required for proper functioning. So probably the body gets tired and the organs will fail over the years and stuff like that. So that's a medical topic we'll not discuss, but I'll give you a basic general analogy here about the impedance compared to the heart system, the blood circulatory system. Yeah, I'm going to return this one to the supplier. It seems that they made an error sending it back to me, or sending it to me. Actually, I never had that one on me. So that's a DAS system. I'm going to complete the job on the antenna and talk to you later in a different video. Do not subscribe. There's nothing to see here. Bye bye.